Hello, welcome back to How to Get an HD in Business Modeling. I'm Reza, and today we're looking at a question from chapter 10. Question 30 says, being connected is very important to people of all ages these days. One way people stay connected is by sending text messages. Suppose a study was conducted at a major state university to determine whether the mean number of texts sent by day differed between male and female undergrad students. 40 female students and 35 male students participated in the study. These students were randomly selected and the number of text messages they sent on a particular day was recorded. The students did not know which day was going to be used in the study. The following statistics were computed. So we have male and female, two independent groups, and we have mean and standard deviations of each of these groups. Using an alpha level equal to 0.05, conduct the hypothesis test to determine whether there is a difference in the average numbers of text messages sent by males and females. Okay. The first step always is to write the null and alternative hypothesis here. We want to see whether there is a difference between male and females in sending text. So basically the null would be mu1 equal to mu2, and the alternative would be mu is not equal to mu2. That's quite straightforward because we are checking whether there is any difference between these two. We don't have any direction, which one is higher or which one is lower. We just want to know, is there any difference or not? The other information is giving you is the mean and standard deviation of the sample. So you have two groups, males and females, and you have mean, standard deviation, sample size. These are given to you. So mean for males are 32.4, standard deviation is 13.9, sample size is 35. Mean of females is 54.3, standard deviation 14.8 messages, and sample size is 40 female students. Okay, write down the information that's given to you. That's going to help you to identify what you need to do, and it's quite helpful to summarize the question. Now, to draw the distribution, I know that based on the null and alternative hypothesis, I'm dealing with a two-tailed test. So that's 0. So therefore, rejection area should be on the two-tailed, both tails, on the right and the left. What is the confidence level? Alpha given to you as 0.05, so 95% confidence level. 95. So therefore, this is 2.5 rejection area. This is another rejection area, 2.5. So I just highlight the rejection area. It's quite important. Always highlight the rejection area. Rejection area. This is also rejection area. Okay. Remember, when you have hypothesis testing, you always need to compare the critical value with the stat value. So I need to have two critical values, and because this is a sample and I don't have any information about the population, I'm working with t-values, so that's quite straightforward. So a minus t and a t. To find the t value, t critical value, I just need to know what's the degrees of freedom and what is alpha. And I also need to know whether it's a two-tailed test or one-tailed test. It's a two-tailed test. Two-tailed test. So what is degrees of freedom? When you have two samples, two independent samples, degrees of freedom is n1 plus n2 minus 2, which is 35 plus 40 minus 2, which is 73. Okay, I need to go to the t-distribution table. So degrees of freedom are given here. I'm dealing with a two-tailed test and alpha is 5%, so that's the column of interest. That's the column of interest. And degrees of freedom is 73. I don't have any 73 here. If I want to know the exact value, I need to use an Excel or another software, but for the sake of your exam, I go with the closest to 73, which is 70. So 1 point, this is the value, 1.9944. So this information give me T critical as basically plus minus 1.9944. So that is minus 1.9944. That is equal to 1.9944. Okay. So the next step is to find T-stat. T-stat, and I have two independent samples, is calculated using the formula as x bar 1 minus x bar 2 minus mu 1 minus mu 2. Remember, in the hypothesis testing, that factor is always 0, so you don't basically need that section, over pool standard deviation times square root of 1 over n1 plus 1 over n2. I know x bar 1 and x bar 2. I know n1 and n2. I don't have SP. SP itself has a formula, so let's write it down. SP is square root of n1 minus 1 times the standard deviation squared plus n2 minus 1 times s2 squared over n1 plus n2 minus 2. If you're not remembering what was the degrees of freedom, you can always look at the degree of, look at the denominator of SP and the pool standard deviation, and you can actually find the formula for degrees of freedom. So if I plug the values, I have everything here. Would be 35 minus 1 times 13.9 squared plus 40 minus 1 times 14.8 squared over 35 plus 40 minus 2. And that would be equal, if you solve what's the value under the square root, you should get 207.0096 cubed 4 decimal places as it is, and the square root of this value would be 14.3878. So I have SP now. I can actually plug everything now into this formula. So T-stat would be x bar 1 is 32.4 minus 54.3 over 14.3878 times square root of 1 over 35 plus 1 over 40, and that value you're going to have minus 21.9 in the numerator and 3.3301. That would be equal to minus 6.5764. Okay, now I change the color here. So minus 6 point, that would be T-stat. minus 6.5764, much lower than minus 1.9944. Okay, so what's the conclusion? We can say that T stat is less than T critical, which basically minus 6.5764 is less than minus 1.9944. That tell you that you would reject the null hypothesis because you are in the rejection area. So remember that this area is the rejection. Now I'm turning it to green. T value, T stat value is lower than that. Therefore, we can say that the mean number of text messages sent differs between males and females. I don't know if you've seen, I think probably that's out of the window that you have, so I just put the T stat here so you can see T stat is minus 6.5764. Now you can see that probably better. Okay, so T stat smaller than T critical, you would reject the null hypothesis. Okay, always remember to do the interpretation. That's quite important, and that's it. Thank you for watching this video.